Hello everyone. In this session we are going to study about the reciprocity theorem. In this theorem we have to study about the statement and the problems of the reciprocity theorem. The statement of the theorem is any linear network, bilateral linear impedances and energy sources, the ratio of the voltage E introduced in one mesh to the current in any second mesh is the same as the ratio obtained if the position of the E and I are interchanged, other EMF being removed. What they have given, right? We have given the impedances. Right. These are the impedances. We have to supply the two voltages are there. V1 and V2 with respect to current I1 and the I2. Yes, two voltage sources are there, two current are there. What the statement is telling, in any linear network, one voltage they have removed. Yes, Z1, Z3, Z2, Z1, Z2, Z3, I1. We have to remove this one. You can short equals to Z1, Z2 and Z3 equals to this one more voltage source of the mesh. It is V2, V1, I1, I2, I2. This equals to this we can prove by this statement. Right, what we have to do? Apply the KVL and we have to find out the first equation. Yes, apply KVL. First, this one, V1 equals to, correct? What will you get that one? Minus V1, V1, this one is of negative to positive, plus V1 minus I1 Z1, correct? Minus I1, this one is a common, Z3, I1 minus I2 equals to 0. V1 equals to Z1, I1 Z1 minus Z3 I1 plus I2 Z3. Correct? This one we can derive from that one. I1 takes a common minus Z1 plus Z3 minus of I2 Z3 equals to minus of V. We can remove from there. Next, KVL to loop 2. Yes, minus Z3 I2 plus Z3, minus I2 minus I1 equals to 0. Right? Minus Z3 I2 minus Z3 I minus Z2 I2 Z3 I2 plus Z3 I1 equals to 0. Correct. take a minus common, correct? I2 equals to, yes, I2 equals to what we have got that one? Z3I1 minus I2 takes common, Z2 plus Z3 equals to 0. Take a delta for that one. Language equation Z1 plus Z3 minus, next it is a Z3. Next what we have to write? Z3 minus Z2 plus Z3, right? By this equation we will get, directly I have to written Z1 Z2 plus Z1 Z3 plus Z2 Z3. It's a delta. By the I2 we have to find out by that equation, correct? I2 it is minus Z1 plus Z3, correct? Minus V1 we have taken V1, correct? It's a Z3. This I2 makes constant, it is a 0. Voltage is 0. Next what we have got it from that one? Minus plus V1 Z3 divided by delta value Z1 Z2 plus Z1 Z3 plus Z2 Z3. We got to know that one. This one is a equation, and then we have to find out that one. V by I2 equals to V1 by I2 equals to what will be Z1 Z2 Z1 Z3 plus Z2 Z3 divided by Z3. This one we have got it from the equations 1. This one is called as a equation 1. Next is the equation 2 for that one. What we have to take that one? We have to close this one, open, plus minus V2 Z1 Z3 Z2 I1 I2. Right, apply KVL again. Minus I1 Z1 minus Z3 I1 minus I2 equals to 0, minus I1 Z1 Z3 I1 plus I2 Z3 equals to 0, minus I1 Z1 plus Z3 and 2Z3 equals to 0. Correct. KVL to loop 2 I2Z2 minus Z3 I2 minus I1, correct, equals to V2 minus V2. Z2 plus Z3 plus I1 Z3 equals to minus V1 I1 Z3 minus I2 into Z2 plus Z3 equals to minus V1. Correct? This one is equation 2. Write it here. You can get the delta same from that previous expression. Yes, minus Z2 plus Z3. You can get the same delta Z1 Z2 divided by Z1 Z3 plus Z2 Z3. You can get the same result, but here it is a I2 equals to I1 equals to, what will you get that one? This one is V2. Here what it is a 0? It is a 0 Z minus V2 divided by minus Z2 plus Z3. Z3 equals to 0. Correct? V2 Z3 divided by delta Z1 Z2 plus Z1 Z3 plus Z2 Z3. I1 by V2 equals to Z1 Z2 plus Z1 Z3 plus Z2 Z3 equals to Z3 by equation. Comparison between the equation 1 and 2 equals to what you have given. I2 by V1 equals to I1 by V2. This is your solved equation. Correct? This is a reciprocity theorem. Yes, next problems on the reciprocity theorem. Yes, prove the reciprocity theorem. First, we are going to take the example of that one. It is 2 ohm, 3 ohm, and this is RL. It is a 2 ohm resistor, and then it is a plus and minus voltage source. It is a 10 volt of the supply, and the next it is a this is also a 1 ohm resistor, right? Apply the KVL to A and B are the two network terminals. It is a mesh 1 and this one is a mesh 2. Apply KVL to that. 2I1 the current, I2 plus 3 common here, I1 minus I2 equals to 10 volt. It is a negative to positive. It is a circuit. Then apply 2I1 plus 3I1 minus 3I2 equals to 10 volt. 5I1 minus 3I2 equals to 10 volt. Equation number 1. The apply to the KVL second loop. Loop 2. This theorem 1I2 correct plus 3I2 minus I1 equals to 0. It is a 2 ohm equals to 5I2 minus 3i1 equals to 0. We have to take the equation 1 and 2. We have to find out the minus 3i1 plus 5i2 equals to equation number 2. Right? 5i1 minus 3i2 equals to 10 volt and multiply by 3 on this one, it is 9i1 minus plus 15i2 equals to 0. Multiply by 5 here, 25i1 minus 15i2 equals to 50. These two get cancels, plus 5, 16i1 equals to 50. We have to calculate i1 equals to 50 by 10. i2 equals to 25, 50 by 10, it is 5. i1 equals to, i2 equals to 25 into 5 equals to 15 i2. 5 ones are 5 threes are, i2 equals to 25 divided by 3. This one is a i2. Correct? Then we have to change the circuit. This is a common. For this one is a positive and negative. This one is your 2 ohm, 3 ohm and 2 ohm. Right? We have to calculate the I1 and I2 equals to 2i1 plus 3, i1 minus i2 equals to 0, 5i1 minus 3i2 equals to 0, equation 1, equation 2 loop 2 equals to minus 2i1 plus 3 into I1, I2 minus I1 equals to minus 10 volt, because it is from the positive to negative in this direction, that's why equals to minus 5i2. This one is a plus and this one is a plus. 5i2 minus 2i1, 3i1 equals to minus 10. Correct? Minus 3i1 plus 5i2 equals to minus 10. 5i1 minus 3i2 equals to 0. Multiply by 5, multiply by 3 equals to 15i1 plus 25i2 equals to minus 50 volt. Right? Plus 15i1 plus minus 9i2 equals to 0. Get cancel. 14, 15, 16 minus 50. Yes, it is not a 16. Just a minute. It is not a 16. 50 divided by 16. I1 equals to I2 equals to 25 into 50 divided by 16. 25 5s are 125 divided by 16 equals to 15 I2 250 divided by 16 into 3. It is a getting I2. Here also 16 minus I2. I2 equals to minus 50 divided by 16. I1 equals to 250 divided by 16 into 3. With the minus sign we can get, it is in the positive sign we got it, and here it is a negative sign get it, means that reciprocity theorem means one is in the clockwise direction, one more in the anti-clockwise direction. We can get the result is here from the this one. I1 is matched to I2 of the reciprocal. I2 of the reciprocal, then I2 equals to I1 of that reciprocal. The reciprocity theorem has verified. Yes, thank you. In the next session we can start about the two-port networks. Thank you one and all.